Hello friends, very most welcome to all of you in this our online lecture series. Friends, as you know, we have started paper Relativity and Statistical Physics. Friends, today in this lecture we will continue in our lecture series, and in this series we will discuss here the Galilean invariance. Friends, firstly we want to repeat previous lectures, the result of previous lectures. As we have told you, the velocity and acceleration, velocity or acceleration under Galilean transformation, and we have seen the velocity of particle is not invariant under Galilean transformation, and acceleration is invariant under Galilean transformation. The velocity of particle we have found u dash is equal to u minus v. Here u dash is velocity of particle relative to frame s dash, and u is velocity of particle relative to frame s, and v is frame of reference velocity, uniform velocity of frame of reference s dash. From here also we can write u is equal to u dash plus v. These results are called Galilean law of velocity. Friends, this result we have observed if frame S is at rest and frame S dash was moving with uniform velocity, and in opposite of this result we will obtain if frame S is moving with velocity v, or we can say that in other words we will observe the same result if from or relative to frame S, or we can say that the frame S is moving and S dash is at rest position, then we will get this result. And also we have proved the acceleration a dash is equal to a, that is acceleration is invariant under Galilean transformation. Friends, now we will see here the Galilean invariance. Firstly, we will see here what is definition of Galilean invariance. Friends, the concept of classical or Newtonian physics is known as Galilean invariance. In other words, we can say that the all fundamental or basic physical laws are invariant in all inertial frame of references. Here we can write two definitions. One definition we write here, the concept of classical or Newtonian physics are called Galilean invariance. Galilean invariance. Firstly, we will see here what is Galilean invariance in simple language. If we want to see here, then in very simple language we can write here the definition of Galilean invariance. The all or we can say that in other words, all fundamental laws of physics are invariant for all inertial frame of references. For all, we can write here, all type of inertial frame of reference. Friends, here we will prove also with the help of some examples. First example is Newton's law of motion, and second example is law of conservation of momentum. We will prove here, and also we will see here this result with the help of these two examples. Here we can see that, in other words, the basic physical laws of motion or basic physical laws of physics are invariant for all type of inertial frame of reference. In other words, in other language, we can write also. Now we will take here, first example is Newton's law of motion. Newton's law of motion, and also we will prove here Newton's law of motion are also, it is also called fundamental laws of physics, and we will prove here this law is also invariant in all type of inertial frame of reference. Either frame of reference is at rest position, inertial frame of reference is at rest position, or it is moving with uniform velocity v. So according to Newton's law of motion, or we can say that Newton's second law is fundamental law of motion, if we exerted external force F upon any particle or any mass which we have chosen M, then according to Newton's second law, it will be F is equal to dP by dt, or we can write here d by dt mu. In vector form we can write here also. Here u is velocity of particle and m is mass of particle which is independent of velocity. Then m into du by dt is equal to ma. Here we have found F is equal to ma. Remember please, here m is independent of velocity. This result we have found in inertial frame. Frame always will be inertial, we have told you in previous lectures, in frame S. Now friends, we will see everything in frame S dash. Now if everything in relative to frame of reference S dash, in relative to frame of reference S dash, then we will see here the force will be F dash and mass M, and result here we have found, we can note it, F is equal to MA in S, in frame S, and we have supposed it is equation number 1. Then it will be F dash and it will be P dash dt dash and U dash, here U dash A dash dt dash, and the result will be F dash is equal to MA dash. In frame S, F dash is equal to MA dash. This result we have found, it is, we can suppose equation number 2, and in S dash. The same example we have chosen 2 times, one times relative to frame S and next times relative to frame S dash. Then we have found these 2 results, equation 1 and 2. But friends, as we have told you, in inertial frame of references, since we have discussed, we know that A dash is equal to A. If A dash is equal to A, then from these 2 equations, from equation 1 and 2, from equation 1 and 2, we can write here F is equal to F dash or F dash is equal to F. Hence, we have seen here the Newton's law of motion are invariant in 2 different type of inertial frame of reference, S and S dash. And remember please, S was at rest position and S dash was in motion with uniform velocity v. Then we have found the F is equal to F dash. That is, Newton's second law of motion are invariant in 2 frames, 2 inertial frames. Now we will take here the next example, the law of conservation of momentum, and we will prove here it will be also invariant. Second example, law of conservation of momentum. Friends, firstly we will see here what is principle of law of conservation of momentum. According to statement of law of conservation of momentum, if any external force exerted upon any system of particles is absent or is zero, then the linear momentum of that system will be conserved. Here we can write according to it, if any external force, is absent upon any system may have many large number of particles, or maybe consist of many large number of particles, 2 or 3 or more than 2 or 3, then its total momentum will be conserved. That is P1 plus P2 plus P3 and so on before collision is equal to P1 plus P2 plus and so on after collision. Here net momentum before collision will be equal to net momentum after collision. Here we have chosen, if we will consider the system have many large number of particles, system is consist of many large number of particles which have masses m1, m2, m3 and velocities u1, u2, u3 and so on, and final velocities after collision become supposed v1, v2, v3. Here we will take here example in following steps, but according to law of conservation of momentum we can see these results. Now we will prove this result. Now for proof of this result we will consider here firstly in frame S which is at rest, let any system consist of two particles, so it have two masses m1 and m2. Now we will consider here, let the masses of particle are m1 and m2 and initial velocity and moving with velocity u1 and u2 and moving with velocity u1 and u2 after collision its velocity changes and becomes v1 and v2 respectively. Then according to law of conservation of momentum, then law of conservation of momentum according to law of conservation of momentum, we can write here m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here you can different in u and v. According to my writing, we will write u such types and v such types. Here changing difference in u and v is such types. We will always write u in this form and v in this form. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here we have found the result in frame S. If we will repeat all these things in frame S dash, now in frame of reference S dash, in frame of reference S dash, all these things will be in the form of dash, because the coordinates of frame of reference S dash in the form of dash. Hence, if we observe the same things here in frame of reference S dash, then its velocity will be same here? Answer is no. Velocity is not same here. If we will observe the same things relative to frame S dash, because we have told you velocity is not invariant under Galilean transformation. If we consider the frame S dash is moving with uniform velocity v dash, then since we know that u dash is equal to u minus v, with the help of use of this result, we can write u1 dash is equal to u1 minus v, u2 dash is equal to u2 minus v, and v1 dash is equal to v1 minus v, and v2 dash is equal to v2 minus v. Friends, the velocities will be such types with the help of this result, and this result we have proved in previous lectures. Now we will see here u dash, u1 dash, u2 dash, v1 dash and v2 dash are velocities before collision and after collision in frame S dash or relative to frame S dash respectively. Now we can write here, according to law of conservation of momentum, according to law of conservation of momentum, we can write here m1 u1 dash plus total momentum before collision, m1 u1 dash plus m2 u2 dash is equal to m1 v1 dash plus m2 v2 dash. With the help of this result, we can write here m1 u1 dash will be u1 minus v plus m2 u2 dash, that means u2 minus v, is equal to m1 v1 dash, means here m1 m2 before collision and here it will be after collision. So m1 v1 dash will be v1 minus v plus m2 v2 dash, and v2 dash will be v2 minus. Now we can write here m1 u1 minus m1 v plus m2 u2 minus m2 v is equal to m1 v1 minus m1 v plus m2 v2 minus m2 v. Here minus m1 v minus m1 v will be cancelled out, and minus m2 v minus m2 v will be cancelled out, and we will get here m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That means we can see here the total momentum m1 u1 plus m2 u2 is total momentum before collision, and the sum of m1 v1 plus m2 v2 is total momentum after collision. Hence, the total momentum before collision is equal to total momentum after collision, and this result also we have proved previously in previous steps in frame S. Hence, we can say that we have found the same result if we have observed the same examples in frame S and in frame S dash. Then we can see, or we can say that the all conservation laws of physics are invariant in all types of inertial frame of reference, which is very most important invariance law. Friends, in many exams it has been asked, prove that conservation law of momentum, conservation law of Newton's law of motion, all these things have been asked in many exams. So we have proved the conservation law is invariant, or in other words Galilean invariance, or in other words we can say that the all fundamental physical laws or classical physics, laws of classical physics is invariant in all inertial frame of reference. So today we will stop here and we will discuss next topic of your relativity and statistical physics paper. And I request to all of you, the derivation of its you will repeat many times and remember these results. So thank you very much.